Thank you, Peter. It's my pleasure to invite to the stage Graham Ault. He's the first of our keynote speakers. So, Graham, if you'd like to make your way, I'll do an introduction while you're doing that. Graham is a leading light in future grid policy and projects in several countries. Graham is part of the leadership team for Smarter Grid Solutions, an international consultancy that boasts drastic improvements in performance and significant savings in network upgrade avoidance costs for their electricity utility, policy and government clients. Graham has a strong background in grid modernisation, power system planning, utility business models, smart grid and distributed generation, including resilient transitions to modern grid architectures. He comes to us courtesy of IET, where he has been integral to their Power Network Joint Vision Experts Group, formed to help ensure national electricity networks are ready to meet significant challenges, including EVs, solar and home heat pumps. He is also part of the IET's Future Power System Architecture project, which is assessing the challenges to be faced in the electricity system by 2030 and identifying the new functionality required. So welcome, Graham. We look forward to your presentation.
Thank you very much, Bob. It's a real pleasure to be here. Like British visitors to these Isles right now, I've had a couple of good warm-up fixtures with the provincial IET branches in Auckland and Wellington yesterday. I feel this is like the main test today, though. I'm hoping the performance is good. If it's not, I won't be blaming jet lag, and I'm also hoping not to be too one-dimensional, like the criticism of my compatriots, the Lions. Warren Ball springs to mind. So if it's bad, it's all my own fault, not jet lag or any other reason. It's especially pleasing to represent the IET. I became a member of the IET in 1989 when I started my undergrad studies. Became a chartered engineer and more recently became a fellow. And I'm also, not to steal the next speaker's thunder, member of the IEEE as well, and I've always found that a useful organisation too, along with the IET. So this isn't a partisan presentation you will have from me this afternoon. The outline of my talk is focusing in on decentralised energy. Decentralisation is one of the big topics of the day worldwide, along with decarbonisation, digitalisation, and even a fourth D, the democratisation of energy. There's some fundamental changes happening in the energy domain just now. The area that I've specialised in from my PhD studies through to today has been decentralised energy. So I'm going to give a perspective on that today, and then tell you a little bit about what my company have been doing in that area. That will move us on to the theme of innovation. What we do is a bit disruptive. It certainly caused a few ripples in the UK sector. We are moving internationally, so I'll share a bit of that journey with you as well, because as we think about solutions to the big challenges facing the power sector, innovation is clearly part of that. Innovation is never smooth, and I'll give you a little bit of an insight into how we've found that this afternoon. I only have half an hour. I've got a bad reputation for speaking long, so Bob's going to have his work cut out, but I'll keep my eye on my watch as we go. Okay, so with a bit of pace then. It's not a surprise when we look at decentralised energy. There's lots of hockey stick exponential charts of growth of this, that and the next thing. I've chosen a few of my favourites this afternoon. So this first one is the growth of decentralised or distributed energy resources globally. Of different sorts, and you can see from today, 200,000 megawatts of distributed energy worldwide, something like, going up to 350, 400,000 megawatts of distributed energy. That's a big growth. It's across all sorts of different technologies. That inevitably creates a lot of problems for the power network operators and others who are trying to deal with that level of growth. Solar has clearly been a big part of that recently. In the IET talks I was doing, the stats that we had from the IEA were that 50 gigawatts of solar had been added to the global portfolio between 2014-15. Those are astounding numbers. Closer to my home in the UK, even in one quarter, we added 640 megawatts, taking us up to a portfolio of solar of all scales. So the volume is big, but the scales are quite diverse, from rooftop and houses of a few kilowatts up to 50 megawatt solar farms. That's a big driver of change. It's a big change to the power system. The difficulties that then creates are numerous. The connection problems, running a safe network, running a network within its limits, running an efficient power network and power system is problematic. These are the 6 so different service territories of the 6 DNO companies in the UK. They run 14 service areas. There's 6 companies do that. All the areas in red are where there's significant difficulties in connecting and operating distributed generation. That creates a problem for them as the network operators. It certainly creates a problem for those who legitimately want to develop and own and operate distributed energy assets. Storage has been the big additional new thing that's happened in the last few years. This graph here, it looks a bit preposterous and ridiculous when you look at the size of growth. The bar to the right-hand side is Q1 2017, and it's the storage megawatts installed in the US. So a very big number, but in response to some very well signposted and well planned out kind of initiatives to bring storage into certain parts of the US grids. In the UK, all 200 megawatts of an auction to provide enhanced frequency response for the system operator in the UK went to storage. There's a capacity market auction in the UK as well. There's 500 megawatts of capacity that went to storage as well, and that will be constructed and come into operation in the coming 2 or 3 years as well. So storage, and those are just 2 countries, storage is growing very fast as well, at different scales, with lots of opportunity, but with a few challenges to get through first of all. I think this might be the final example. Electric vehicles clearly is a new growth area as well. Of that 2 million cars that it's estimated that there are worldwide in electric vehicles, over 40%, or around 40%, got to be careful with my stats, about 700,000 of those 2 million have been bought in the last year, so that constitutes a substantial growth in electric vehicles as well. Again, they provide possibility of problem, but also there's some opportunity there too. So the number of challenges, of course, with that. Many of you in this room are highly experienced network operators. You know your power systems. When you start to change the source and the sink of where power is, that creates all sorts of challenges for the infrastructure that you have, the infrastructure that other distribution utilities have around the world, monitoring where that is, operating a system with variable inputs and outputs at different places at different times. That's clearly a big challenge. The commercial challenges as well. How do we pay for that? Who pays for the infrastructure? Who pays for the monitoring? Who gets the benefits out of some new energy assets that are coming into the grids? What services can they provide to the grids? What do they get paid for that and when? There's any number of market and commercial challenges that come along with the decentralised energy. All of that then hasn't happened without governments taking a look. In the United Kingdom, our response has been for the government department responsible for energy, which actually changes on a 6-monthly basis. You might have realised that the UK political situation is quite turbulent just now. So the current government will be picking up on a previous government's consultation on a lot of these changes and publishing quite soon, we hope, if nothing else happens, quite soon a roadmap for the smarter, more flexible energy system. And that's been about 3 years in the waiting because of all the different things that have been happening. But that will track out and map out how we're going to deal with this much more flexible, distributed, and a lot of other things, power system that we have now. Both John Scott and Eric Brown, who I think have spoken here in the past, have talked quite a lot about the IET's initiative, Power Network Joint Vision. So I was a part of that and wrote some of the work on planning a power system with all of those new, uncertain, dynamic characteristics that we've just talked about. And this is one of John Scott's graphics showing the scale of things that are happening. The number of devices connected in different places, able to do different things, the level of participation of city governments through to individual citizens and homeowners. So we're expecting a very challenging time, a very unique time in the development of power systems in the UK and in many other countries as well. And the outcome of this Power Network Joint Vision piece of work here was the Future Power Systems Architecture project, which Bob mentioned in the introduction as well. I'll move on to that now. That's a piece of work that started about 2 years ago. Again, I was involved in that, and that was a real privilege to be working closely with government and regulator and a number of the system experts in the UK. Part of the work they did was to compare what was happening in the UK with a number of select countries elsewhere in the world, where either the growth of renewables or the growth of other things were creating some real challenges. The outcome of an international study then was that the UK is going through this. Many other countries are going through it as well, and to a greater or larger extent in these different technologies down the left-hand side. New Zealand will be going through a number of these changes and challenges also. The outcome of that Future Power Systems Architecture work was the identification of some new functionality that would be required to be built and implemented in the power system. 35 new functions, or new or extended functions. I'll show you the kind of headlines of those in a minute, as well as identifying new functionality required to manage this more complex and dynamic power system. A number of the challenges in implementing those, whether through the code governance processes, whether because of the political uncertainty of governments, whether because of the remit or inappropriately narrow remit of an economic regulator that we have in the UK. There's a number of challenges with bringing those new functions into being as required. The groups of the functions themselves were everything from estimating the state of the system, either in the long run for planning or much more close in for real-time operation. That's particularly critical then if you're looking to run a safe, stable and economic system, but you don't know what the assets are going to do. You don't even know where some of the assets are. If they're electric vehicles, they tend to move around. In the summer, they might be on all the holiday destinations. In the winter, they're somewhere else. So clearly, estimates and forecasts of the state of the system in appropriate timescales is pretty important. Picking one other one then, down at the bottom right there, the markets that are required to allow anybody with a service, with an energy asset that can provide something to the power system, providing the market and commercial arrangements to allow all of those asset owners and operators to play their full role. That's something that the markets just aren't capable of just now. And we do some work in the US as a company, and some of the ISO market changes are about allowing aggregation of smaller devices to participate in markets. That's a welcome change. Reducing some of the threshold capacity levels for different sorts of assets to participate in and provide services to the market. So those are just examples of a number of the changes that are required. There's a number of challenges and barriers then to introducing those new functions. Some of those are technical barriers, maybe it's the codes and standards. Some of those are commercial barriers, as I mentioned there. The markets don't yet exist to allow those different sorts of assets and services to be provided yet. Governance is certainly a big part of that. The complex arrangement between regulator, different government departments, trade associations in the power sector, and any number of other participants in the power sector governance, that makes introducing new change lengthy, complex, and sometimes just downright impossible. Okay, so that's the short. I'll just take a look at my watch, make sure we know where we're going here. That's the context then. Systems getting more complex. Decentralised energy is very much a part of that. So one of the solutions that's coming forward now are a set of technologies to manage distributed energy resources. And what I wanted to do just in a couple of slides was show a little bit of what that means. This is some work that came out of Lawrence Berkeley National Labs in the US, and it's tracking the growth of distributed energy assets, and then in the red text, and that's a bit to look at, the red text down the right-hand side is what has to happen in the distribution system to fully accommodate those distributed energy assets and then actually make good use of them. And so you can see there, whether from monitoring or investing in smart grid infrastructure and technology, all the way up to enabling transactive energy approaches and new market mechanisms. With the growth of distributed energy assets, a lot of those new functions for distribution utility companies are inevitably going to come forward. I'm not sure how you feel about that with the way the sector works, but that I think is a very, very big question. It's a very big challenge for the power sector, for distribution companies who are used to working in certain ways in terms of real-time operation and market approaches of the system to move to something quite different now. We, as a company, have been involved in some of the first DERMS. It sounds like something you'd apply to your skin, but it's a DER management system. Procurement activities are now coming out from some of the larger power distribution utility companies who are faced with some of the biggest challenges with distributed energy resource integration into their networks. The things that they're asking for in the open marketplace are everything from control, how do we control those assets, how do we monitor them, how do we scale up from hundreds to thousands. In California, they're talking about millions of distributed energy assets that they want to monitor and control in some way. So those are very, very big challenges. The technology is going to be stretched, but there's a number of other things that are going to be stretched to be able to provide DER management systems that are capable of that. You can see the list there. That procurement exercise, which unfortunately I can't say who it's from, there was about 800 different requirements in each of those categories. So, very, very extensive thinking going on about how to deal with distributed energy. Okay, so final parts that I wanted to share about was an active network management. As a company, that's the thing we've been bringing forward. It's a set of technologies to monitor and manage and control distributed energy assets. We do that through putting local intelligent devices next to any asset that needs to be monitored or controlled. We do it through also, you can see there in the top right, integrating a central brain wherever that centralization happens, either a substation or a data or control center. And that's quite typical of the architectures now coming forward for distributed energy management systems, is to have locally centralized, so some local, some part way, and some centralized functionality that's delivered to provide everything from coordinating thousands of assets to providing local fail-safe controls as well. So you can see why quite a complex architecture is required. That actually provides a significant challenge for the introduction of a new solution, and I'll come to look at some of the problems with a new innovative, disruptive thing like we're offering, because it cuts across a whole number of different functions, departments, parts of the distribution organisation, from real-time control to planning to equipment to procurement. So this is quite a holistic change that's happening, and that creates its own problems. In the UK, the sector has tried some of this technology. We've been lucky and been a participant in some of those trials and benefited from that, which I'll talk about in a second or two. But that's also allowed the sector in the UK. So the UK ENA, Energy Networks Association, have taken all the learnings from all the innovation and trial projects and bundled those together into a set of general requirements for active network management to provide DER control. And you can see on that slide there in the coloured boxes, from running a connection process all the way through to having a technical system architecture for systems that do the management of the DER. And then secondly, things through to processes and people. So who's responsible for all the different parts of this new, more sophisticated architecture, for interacting with customers, to tell them what it means for them, to inform different customers of what the opportunities are and what the implications of connecting to the network in different ways are as well. And then the bottom box in the green there is particularly important. The transmission interactions are becoming ever more significant. As you have more distributed energy assets, the implication on the upstream transmission system starts to get greater as well. And I'll flick through this. That's some of the further requirements. But this is the transmission implications. National Grid, who are the transmission owner and also the system operator in the UK, they have gone through a process of looking at the implications of different autonomous control systems within distribution networks, and they've concluded for themselves, okay, it's a problem. Okay, if you have lots of assets in distribution networks and you have lots of autonomous, new, fangled control systems in distribution networks, that can make the job of running a coordinated, secure transmission system ever more problematic. And so for them, they've got now some processes and procedures in place to try and coordinate and liaise with the distribution companies to plan out the introduction of these new control systems. I was going to say something about orchestration. Clearly, the way you control distributed energy assets, there's a number of different control philosophies you can do that with. Timers, dead bands, thresholds, escalating actions, hierarchies of control, and all of those have to be thought through, and that's something that we've been doing. The graph on the right there just shows in the red line, that's one distributed energy asset responding to an instruction given to over a 2-minute period, and that provides a down ramp service to keep the distribution network within its limits. And one other aspect of all of this change is what information is available to the operators of this more sophisticated, more complex power system, but also to the customers that are a part of that as well. So going along with what Unison were saying, the amount of data now available from each of these distributed energy assets on secondly basis. What are they doing? How did they respond to control instructions? What were the measurements in the power system? All of that can then be aggregated up to provide much, much deeper insight for customers and for the operator of the distribution system as well. And that's something, again, that's quite new for the control rooms and the planners and the customer liaison people in the distribution companies. On the right-hand side there, the customers themselves may want to bid in to schedule, to inform the distribution company of the availability to provide some flexibility service from their distributed energy assets as well, and that's something that's being worked on as well. Okay, so that's a bit of the story of decentralised energy. It's happening in lots of different ways in lots of different places around the world. Some of the responses to that through DERMS and things like active network management. I wanted to spend just a little bit of time on innovation. The theme of the conference is on innovation. So for us as a company, we came out of a university research project. I was a supervisor of that. One of the other founders was a PhD student. And the third founder was the commercialisation manager to help academics get good ideas into practice. So doing the R&D was great. That's great fun. Did it with a really good supportive power network company, SSE. We had lots of fun doing it, lots of challenge doing it. We got a real system to the point of trial, but then had to make a decision of, well, how do we make this real? How do we commercialise? How do we actually turn this into something that's useful for distributed energy asset owners and operators, and also the power network companies? So doing the R&D is one thing. Establishing a company is another thing, and that's what we did. So our company now focuses, as well as the consulting and policy work that Bob mentioned in the introduction, we've been changing our business model over the years, and now very much we're focused on the control software that we can provide to DER owners and operators and the distribution companies. We've grown, which is good. That's made things more complex for us in a number of ways, and we've had to deal with a number of challenges of any SME company does in doing different things in different places with different customers, maybe across geographies as well. Productizing the outcomes of innovation and research has been one thing we've looked at. So we now have 2 products. I won't do a sales pitch, but it's just to think about the process of turning ideas, trials, results into an actual product that can be taken off the shelf and deployed and used and provide value. That's one part of the innovation journey. Growing is another. So this chart just shows from the early stage research in 2003 up to last year, the growth in customers. We've moved across geographies, so that in there's first projects in Europe, first projects in North America. That, as you can imagine, for a small company, that creates a whole number of challenges which have to be embraced. Unison were saying earlier, they would be taking what they've done, which sounds incredibly clever, to other places as well. It's not an insignificant challenge to do that, of course, as they will know too. Rolling out the product, we've been fortunate enough that we've had some great supportive customers in the UK. We have our systems deployed in a number of places already. Each of the smaller dots there are different distributed energy assets that we have under control and management. 276 megawatts connected. And one of the big things, though, that we've been working on is establishing and sharing the business case for that. And most of that work is with renewable generators, where the cost of the connection and the reinforcement of the distribution system is avoided by a smarter control and management approach, such as we offer. And the bottom right box shows, for 3 of those projects only, the capital savings for the distribution company in avoided reinforcement of their grids. That £100 million that was submitted in evidence to a parliamentary committee in the UK that was looking at the flexibility of the system and the introduction of innovative solutions. So we are particularly pleased that it got those sorts of headlines. Growing pains are part of the journey. All sorts of things that we've had to consider. If you know and have read up on your innovation, crossing the valley of death from innovation into reality, crossing the chasm into a real product. These are all well-known terms. We've done that. Crossing an ocean was difficult for us. We had to send one of our founders to America. He was married to an American, so it suited him just fine. But there's a lot of then time difference problems and many other difficulties as well in doing that. Most companies that are growing go through growth pains, of course. We received a lot of regulatory attention. Ofgem, the regulator in the UK, was very pleased that customers that wanted to connect and operate the network were offered a better deal, an alternative to a fit and forget firm connection. And Ofgem, those are the 5 of the DNO companies in the graph. They were keen to see where innovative solutions such as ours were being offered, how they were being offered, how many customers were taking advantage of that as well. And that's something that we fully participated in too. There's been a number of challenges along the way. We just wrote an article that's in an IEEE magazine this month actually on getting to business as usual from innovation. You can see there any number of challenges, whether it's the business model, the way that distribution utility procurement works, how to get to scale, how to take your clever product and actually start supporting that with a 20-year life in mind, all sorts of things that we have to deal with. Business models actually there for us and for our customers is actually one of the biggest things that we spent a lot of time innovating on now, how to make the rollout of a product and the support of it work for us, and also how to make sure it supports what our customers, the distribution utilities, want to do. And the list of challenges goes on. I've been, as a power systems professor, I never thought I would be responsible for marketing in a company, so that was a rather steep learning curve for me. That's just one of many things that we've had to embrace. So, I think nearly there. The final part then is just a bit of outlook. The market, this is again Navigant Research, one of the first graphs I showed was from them. They've looked at the market for DER management technology. It's growing fast, it's growing fast across geographies, so that's good news for a company like ourselves, but that attracts attention, attracts a lot of competition as well, which is then starts to become bad news for a company like our own as well, and competition is one of our key challenges. One final thing then before my conclusion slide. In North America, the 5 of the state regulators asked the Department of Energy, the federal government, to support a project to try and map out what the next generation, so that's the X part of DSPX, the next generation distribution system platform would look like. So how will a distribution utility in future plan, connect, operate distributed energy assets and other things as well in their system? They've done a very, very thorough job of that. So there's now fantastic blueprints for all sorts of new functions and activities and technologies that a future distribution utility would want to implement. The table on the right there, so the blue bits are the things that are existing. So obviously planning and operating with doing that safely and doing that efficiently is core business today. But as you start to think about introducing market operations, as we start to think about not just accommodating distributed energy assets, but utilising them as a core part of the system to make the system more efficient, that's a big challenge, and there's a lot of new functionality that's required and a lot of new activities required by the distribution utilities to do that. I said the other night, actually, at the IET talk, one of my big failings is to always say finally. I said it halfway through. I was nearly finally. This is the final slide other than my conclusions. So distribution system operator. So moving from, and this is very popular in a number of countries, to move from a network operator to a system operator at distribution is a big step. It's receiving a lot of attention. What does that mean to operate a system with active customers and active devices? We've done a bit of work in the UK starting to map through from passively operating a system through to not just actively operating and controlling a system and planning it, but also to introduce markets into that as well. That's something that is already starting to happen. I think it's something that will increasingly happen, and distribution companies will have to embrace that in one form or another, especially where there's a lot of distributed energy assets and active customers. And so we get to conclusions. So the system is changing rapidly. I think I've shown that just in the area of decentralised energy. The thing that we do as a company is one little part of that, to provide some of the control tools and platforms to allow the monitoring and management of distributed energy assets. We've taken that from research through innovation projects into product and business as usual. I think I've shared with you a bit of the pain and the challenge of that. That's ongoing and will continue to be ongoing. There's a long way to go, but we think certainly in decentralised energy area, there's an awful lot to gain for a system with much more participative customers, lots more assets that can provide flexibility and services to the system. So certainly there's going to be a lot of interesting times as all participants in the system wake up to that and do something about that and take some of the value from those changes that are happening. And with that, Bob, I will stop. I've got no idea how the timing went, but I'm finished anyway. Yeah. Thank you very much.
We do have a few minutes, so are there any questions? I take it you're happy to take questions, Graham. You might like to pose to Graham. Now, is there a microphone on the floor? Please, we have somebody down here. There you are.
Hi, yes, my name's Mike Erskine from GHD over in Australia. A fascinating presentation. The amount of smart grid thinking you're talking about there, the consideration of machine learning algorithms in battery storage, just curious about that at the domestic level and the potential effect on the grid and the broader thinking about artificial intelligence for the whole management. Just be curious to understand.
Yeah, So very good question on AI techniques. And I think, so I won't focus my answer on AI or machine learning or any other technique within the AI family. But autonomously operating algorithms at home level, whether it's Google Nest or whether it's algorithms that operate your water heater. I was talking with somebody earlier about water heating, your electric vehicle charging, a storage device in your home or anywhere else. Clearly that's one of the big fears and threats. If that's developed in an uncoordinated way, then the system gets no benefit from that potentially. The individual customer does, maybe the system doesn't. So I think the Future Power Systems Architecture project, certainly the thinking we are doing as a company, is all about how to coordinate that control into an overall more efficient, more safe, more economic system. So I think the outlook for the smart algorithms of whatever form they are is that they will somehow and somewhere have to coordinate into and integrate into what the overall system is doing for them to be useful and to be safe actually as well.
Do we have a further question? Thanks, Brian.
I'm bemused totally, I'm afraid.
You're, sorry?
I'm bemused.
Okay.
If you want to reduce carbon dioxide, which is presumably the objective, nuclear power and converting from coal to gas do it better and cheaper. So forget that as an objective. Wind and solar power do not exist without subsidies, and this is proved by the experience in Spain. Subsidies stopped, new installations stopped. So what you're giving us is a very expensive way of integrating a very expensive source of electricity into a power system and making it ever more complicated, more unreliable, and it's unbelievable. What will happen if your communication system fails? What will happen if you get a system collapse? How can you put this back together? And how long will the consumers put up with this ever-increasing unreliability and ever-increasing cost of power? It seems to be a crime against the ordinary poor consumer.
Okay, there's a number of questions there and a number of very deep topics. I'm not going to attempt them all. I would love to, but I think I would test the audience's patience by doing that. So the decision to take on some of these technologies, that's a political decision, and that's based on the evidence of climate science. Okay, so that's a given for us. If it's happening though, and some of it is happening at small scale, the rational response is to have technologies that can monitor and manage that to deliver the safety and security, the economy that you talk about there. So I suppose what I would say for our solution, I've got views on climate change, I've got views on decentralisation of energy, but sticking close to home, what we're trying to do is provide a set of tools that if people want to go down this route, it allows them to do that efficiently and well. And I think that is a rational response to what's happening.
Thank you, Graham. One more question, got time for? To the left there.
Hi, it's probably two questions. I just wondered, because you mentioned about the limited observability in the distribution part of the network, so how are you dealing with that? And maybe it's probably a different question, but what new monitoring systems might be useful to solve the lack of observability in your mind?
Yeah, okay. Yeah, it's a very good question. I think I suppose one of the kind of uninformed responses to that, exactly that question as well, if we've got all this new complexity, all these new devices, all these active customers, we'll just have to monitor everywhere, and create, ever greater sets of data. Our approach to that, and again, this is close to home for myself and my company, our approach to that has been to simplify that as far as possible. So only to monitor and measure strictly what's necessary. So you do all your design work, your planning work, identify where the critical measurements are to enable you to then control the distributed energy assets, and that then takes out any notion of, so state estimation, observability analysis. You don't have to construct a full network model. You don't have to have numerical methods to achieve that. You're only monitoring the thing that's really of importance to you, a flow, a voltage, receiving an instruction from a system operator, a network operator to do something, and then you know exactly which of the distributed energy assets are going to do that for you. So our approach has very much been, simplify all the way back. Just so happens though, I think where your question's coming from is with the advent of smart meters, ever cheaper sensors, ever cheaper communications, we can start to embrace the idea of monitoring, more places and down deeper into the voltage levels of the network. So what we do with that data, well, I guess that's for another day for us, certainly. We're sticking to something a bit more straightforward to start with. Those, on the last thing, sorry. The big long list of requirements from the DER management system procurement that I mentioned there, quite a lot of that is about where the data's coming from, where it's going to live, what applications are going to access and use it, what they're then going to do with that. So I think that notion of more prevalent measurement and data, and then the important thing is the valuable use of that data, that's certainly coming through. That procurement exercise is one of the recognised, more progressive distribution utilities in the US, so it's not a surprise that they're taking a very tech-led kind of view of the world.
Thank you, Bob. Thank you, Graham. Good afternoon, everybody. It's my job and my pleasure to give a vote of thanks. So let's call it a vote. Let's have a show of hands. Let's take the New Zealand context. How many of you think in 10 or 15 years' time we'll have more EVs on the road, there'll be batteries within the distribution or transmission network, or there might be more solar panels on their people's roofs? Let's have a show of hands. I know how Brian's going to vote, by the way. Can y'all see through the spotlight? So that looks like quite a show of hands to me. So Graham, I think we agree with your slide 13. If you had New Zealand on your little boxes there, we'll have a few ticks in that as well. So how many of you know how much is going to come along? How many of you know how it's integrated? How many of you are worried about control and how we're going to allow adaptation of some of this technology, whether we've got the choice or not? And I think, Graham, you raised some extremely good points there, that there's a lot of research around the world happening to look at what could be done here. And if you don't know how you're going to solve it, I look at you, and I say you, because all of you out there are involved in the power industry to some extent. How are you going to apply some of the techniques or some of the systems that Graham and his team or others around the world have adopted, or developed here in New Zealand, to help either integrate this stuff or minimise disruption of it being integrated? Graham, you talked about the R&D side. I was really, really impressed that your regulator was happy. I hope our regulator's happy, but only time will tell. So can you please put your hands together for Graham and his marvellous presentation? Thank you.